So that was work. This was a dot product. Then we showed here, we talked about the right-hand rule. Right? We talked about our right-hand rule, that when I was dealing with my change in angle, and I looked at a change in angle with respect to time, and I go around and my fingers come up, I have a direction. And I would get the angular velocity. This is going to be a vector, that's going to be a vector, but my direction will come out of the page. So if this page is an x, y coordinate system, my angular velocity is going to be, if I write a vector, it's going to be a in the I direction, which is my x direction, a in the j direction, which is my y direction. And if I'm in 3 dimensions, I get a in what we call the k direction, what's in my z. And in this case, my z is coming out of the page. So omega is going to be in the direction that's either into the page or out of the page. And in this case, we say out of the page is positive and into the page is negative.
So what's that sign I can't?
This sign,
Uh-huh.
it's just what it's called a caret. It's a little kind of a triangle on top. What that represents, if I have a k caret, that's a unit, meaning it has a magnitude of 1 in the k direction, which in this case is z. The caret just tells you it's a vector. The caret tells you it's a unit vector. And we've done it for I, and we've done it for j when we dealt with vector notation early on. Okay, so we have something that's got direction associated with it. So let's think about, and I love this part, because this is general physics class. Okay, general physics class has a good mix. So this is audience participation time. I love this part. Audience participation. You have a flat tire. Okay? You have a flat tire and you're on the side of the road. Depending upon your vehicle, you are likely to have one of the following in your trunk. You are likely to have this kind of tire iron, or you're likely to have the old-fashioned kind of tire iron that's like that. So out of curiosity, how many of you would prefer this one? I want to show of hands. Audience participation, over there in Enid, how many want that one? I want to find it interesting. I've got interesting ones. All my sports athletes back there. That's interesting. Okay, I want to see the hands in Enid. I want to look at the hands in Enid. How many want this one? Okay, all right. All right. How many want this one? There is no right or wrong. They both work. This is the first time that's happened. All right, put your hands down. Generally, the majority of you who are female will pick this one. Generally, the majority of you who are male will pick this one. Except for my horse athletes. My equine athletes will pick this one 9 times out of 10. That's why I'm not surprised that my athletes back there picked it. Okay? What we're going to find is either tool works effectively well. The reason that women will generally pick this one over this one is because how we apply the force. All right? How we apply the force. Because if I'm applying the force on this one, I am applying the force all the way at the end, because I got my lever arm right, and my lever arm, I'm applying all my force there. If I am using this one, I am applying a force downward here and upward there. The magnitude of the force in both cases is the same. This one I'm splitting it up over 2 lever arms. This one I am not splitting it up over 2 lever arms. This is what they call in engineering a couple. And this is the same kind of thing that if I'm taking a wheel and I am turning the wheel like this and applying the force like this around the center point, I've got that part. So that's one of the things. The reason that women generally do this is because we do not, females don't tend to be able to apply equal amounts of force with their rights and left sides. If they're left hand dominant, they're going to apply more force with their left hand. If they're right hand dominant, they're going to apply more force with their right hand. That's why I say my equine people who have trained themselves to be ambidextrous, because the horse is going to make you be ambidextrous, are more likely to be able to apply relatively close equal amounts of force. And for whatever reason, men can do it a lot better than women can. It's just a biological difference. The other reason that women will do this is because some of us do not have upper body strength enough to do it, and we're not going to use our arms anyway. We're going to jump on it, and this gives me a better lever arm to jump on. Because there is no way I'm freaking breaking the bolt on my car to get the tire off. Then, there's no way I may have to sit on it in order to break the bolt to get it to move. And that's why I want a lot more lever arm to do that on, because that sucker's too short. Okay? And so that's one of the reasons it's there, which leads me to a very amusing story. We were traveling with the horse trailer with 2 horses in the back on our way to Pagosa Springs for a week, and we started hearing a funny noise. Funny noise was my ball hitch was coming loose. I'm in the middle of western Kansas. Okay, I'm not even on I-40. I'm taking back roads because we're going to Pagosa Springs and we don't want to go all the way up to I-40. So I'm on the back roads in western Kansas, and the ball hitch is coming loose. Not a good plan. My spare road kit and in the car, which I always travel, especially when you're traveling with horse trailers and everything like that, does not happen to have a wrench that is going to fit around the nut on my ball hitch. So we're kind of in a predicament. We're in a little bit of a predicament. So we kind of go, okay, well, we'll tighten it as best we can. We'll go slow. And as soon as we hit the next 4-corner stop that has a gas station, hopefully somebody's coming in from feeding cows, doing whatever they need to do. And they're going to have some equipment that maybe we can find a wrench that's a little bit tighter or bigger than the one I got, which we did. Came in. We asked if we could borrow it. And he says, oh, I'll do it for you. And he happened to have a wrench, and he was working on equipment. And I swear this thing had a 2.5-foot arm on it, which is a good thing, sort of, because not only did he do that, he hauled on it, applied a lot of force. I thought he was going to shear the bolt. I thought he was going to shear my ball hitch. And then he calmly looks at me and he says, ma'am, I think you ought to have it checked out when you go to the next town. Everybody in the car, we all got in the car and did this and covered our mouths going, I don't think, to this day, we haven't gotten that sucker loose. I didn't need a torque wrench because he applied it pretty well. So we use torque to our advantage all the time. A couple is what we're going to get from an engineering point of view, because I can add these forces, and if you think about what's happening here, if I add these forces, if I'm looking at it like I'm looking at a wheel, this is going to cause my wheel to turn that direction, this is going to cause my wheel to turn that direction, so I'm going to be able to add up the forces. And it will be the same as doing this, okay? It's the same as applying it on my tire iron this way. So torque becomes my second tool. So if I look at it, remember our first tool? When we started doing work, we did our first tool, and we said, this is a really cool tool. We said, all right, if I did this, and I apply a force here, and to raise up here, I'm applying a force, and the work here, the work into the system had to equal the work out of the system, and in that case, it was a scalar quantity, right? It was a scalar quantity, we used it, but we disregarded what was happening here. We disregarded what was happening here. If I'm doing this lever, I'm causing this to rotate around. So in this case, when we looked at work, we were disregarding the rotational motion. We weren't disregarding it, we just weren't concerning ourselves with it. Now, we've all played with this scenario, right? We've all played with it. And this is the famous algebra question, right? We do the algebra question. If I have the little kiddo here on this end, and I have the bigger kiddo